Good evening everyone. Today we are going to do the daily Leetcode challenge of 6 March 2023. That is question number 1539, kth missing positive number. We are given an array and we have to return the missing number, and the array is strictly increasing order. So move on to the example. What they want to tell you is that the array is strictly increasing. That it start from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11, and this array is strictly increasing. That means we have to return the missing number. So when we see that the first missing number is 1, second missing number is 2 is there, 3 is there, 4 is there, 5, then 6 is the third missing number, 7 is there, 8 is the fourth missing number, 9th is the fifth missing number. So that we have to return. It is as simple as that. It is an easy question. You can easily do it in O of n, but the time complexity to be reduced to O of log n, we use binary search. So we will see both the approaches. Let's start with the O of n approach, that is the linear approach. For that, what we will do, we will make a variable number. We will initialize it with 1, and we will decrement the size of k. K is initially 5. We check whether this 1 is equal to the first element of the array. No, it is not equal. So we decrement our k to 4. And we always increment our number. Now 2 and 2 are equal, we don't do anything. Then we move on Ri, then and we also increment our number, that is 3 and 3 both are equal. Very good. Number is increased to 4. I is here. 4 and 4 both are equal. Very good. When it comes here, 7 is not equal to 5. That means we decrement our k. Then we increment our 5 to 6. 7 is still not equal to 6. So we decrement our k to 2. And we increment our 7. Number to 7. 7 is equal to 7. So we do nothing. We increment our I. Now it is 11. 11 does not equal to 8. We increment its value. Number is always increasing. 11 is not equal to 8. Then we decrease it. And finally, when 11 does not equal to 9, our k becomes 0. When this k becomes 0, we return our answer. That is what you have to do. You will simply run a loop, and it is easily done in O of n. Let's code this, and after that we will see the binary search approach. So we start with int n is equal to arr dot size, and we will make a variable int I is equal to 0 while I is less than n and k is greater than 0. What we will do? We will check if nums of I is equal to number, and we have to make a variable number. Int num is equal to 1, and it is arr array. It is equal to number. Then what we do? We increment our I. If it is not equal, we decrement the value of k, and after that we are always increasing our number value for the comparison. But in the case of second example, there's a hidden test case. Let's see. By our approach, if you see in this example, we have to give the missing second number. Our number is initialized with 1, k value is 2, 1 is compared with 1, it is same, it is incremented to 2 is compared with 2, it is same, 3 same, then 4 is same. So our this condition is satisfied, so we will exit this while loop, but our k is still there, so we will make another while loop till this k decrements. That is, after this 5 comes, so we decrement its value to 1. Now after this it becomes 0 and it is incremented to 6, so our answer would be 6. So we need another while loop that says while k is decremented, if k still exists, decrement the value of k till it becomes 0 and increase the number value. And finally we will return num minus 1. Why num minus 1? Because we are starting from 1. So technically we are at the 6th value of the number value is 6 when we have to return 5 in the fifth missing number. Because you are starting from 0 na initially. Make a dry run and think about it. It is num minus 1 if you think about it carefully. Because you are starting from 1. 1 is compared with 1. That is what I want to say. So let's just run it. So yeah, it is running. Let's just submit it. So yeah, it is accepted. Now let's move on to the binary search approach. That is a good approach. You should think about it before watching the video and then come back to the video after you have given yourself a try. So I hope you tried the binary search approach on your own. Now let's see how can we actually do it. So our array is this. Let's try, and our actual number should be 1, 2, 3, 4, and 5. If we compare these array with this, at the place of 2 there should be 1, at the place of 3 there should be 2. So this should be the array actually. So if this is actual array and this is the value that should be there in the place, so if we have to find the missing values before it, if we do 2 minus 1, we will get the value as 1. That is 1 is missing. That is 1 is missing. If we do 3 minus 2, we will say one value should be missing before it. If we are at 4, we will say that one value is missing before it. If we come to 7, that is 7 minus 4, we see 3 values. That is 3 values are missing on the left of it. Okay, and if we come to 11, that is 11 minus 5, that means 9 values are missing on the left of it. So that is what I want to tell you. So instead of making another array, we can simply do it by using index number, that is 0, 1, 2, 3, 4. So if we do every time, that is number I minus I plus 1, we will know how many numbers are missing on its left. Yes or no? We don't have to just observe it like a fact. We should know why we use this formula, how we came up with this formula. If you observe it carefully, you can find it. Now let's apply the binary search on it. So let's say our array is this, 0, 1, 2, 3, 4 is our this. For binary search, what we do, we make a start variable that start with 0, and we make a end variable that start with the last index, that is size of array is 1, 2, 3, 4, 5. 5 minus 1 is 4. So end is at the fourth index, start is at here, start and end. And binary search goes till start is less than equal to end. So first we get the value of mid. What will be the value of mid? Mid will be 2. 4 minus 0 by 2, that is 2. And our formula was number of I minus I plus 1. So number of I is 4 minus index is 2 plus 1, that is 3. So value comes to be 1. So there is one missing value on its left, but we have to find the fifth missing value. So we will update our start to mid plus 1 because we will not get our answer on the left side. So our start comes here at the third index, our end it as fourth index. So what will be the middle point now? That is 4 plus 3 by 2. That will be 7 by 2, that will be 3. So 3 is the middle point. So our middle point is at here. Now if we count this formula for 7, 7 minus 3 plus 1, it is 7 minus 3 plus 1, so we will get 3. So we are getting that 3 missing numbers are behind it, but it is still less than 5. So we update our start to here. So at that time our binary search will stop. So our start value comes out to be 4 at that time. And if you check where in this formula, that is 11 minus 4 plus 1, so we are getting 6. That means 6 values are missing behind it. So our answer can be there, but how do we get answer now? That is the main step. So our start it as fourth index and we have to find the fifth missing index, so we add it and we get the ninth number. So how is that actually happening? How we can say that start plus the k we are always getting the right answer? Let's see here. Suppose if we have to find, let's see here where we have written all the numbers 1 through 5, 6, 7, 9. So when we say that we are at the fourth index and we are adding 5 to it and we will get this 9, how we are actually saying that? The first missing number is this, second is this, third is this, and fourth is this. So we have covered those 4 numbers and we have to find the missing index. So that will be the addition of k to it. You can check for different cases for this and you will come to the same conclusion. Please try some different test cases and dry run it, and then you can easily see that yeah, it is working. Whenever we add the start with the missing k value, we are always getting our answer. So let's just code it and see whether it is really working or not. I hope you are understood the binary search approach. If you have any doubt, do let me know in the comment section. So let's write it. Int ann is equal to array dot size, int start is equal to 0 and is equal to n minus 1, while start is less than equal to end. What we do, we get the value of mid is equal to start plus n minus start by 2. Why we are writing it this way? To avoid buffer overflow. After that, if we also need to get a variable that is int missing till mid. How many number are missing till mid? So how will we get it? We will get it by uh, array of I minus I plus 1. Yes or no? And what is I in this case? This will be mid and this will be mid plus 1, because we are getting the missing values for the mid values. Yes or no? Mid value, this is a mid. So that we have to check if this missing till mid is less than k, we update our start to mid plus 1, else we update our end to mid minus 1. And when we are done with this, we will exit our loop and we will return start plus k. That's all you had to do. Let's see whether it is working or not. So yeah, it is running. And yes, it is accepted as well. So I hope you liked the video. I have told you both of linear complexity and log n complexity. Space complexity is constant. Please like, share and subscribe. Thank you so much for watching. Make sure to subscribe. It motivates me a lot. Bye bye. See you in the next video.